Hi guys! My hope is to cover classifying life with you in just this one short video. I don't think it'll take any longer than 10 minutes, but classifying life is one of my favorite topics, so I'm really excited to share it with you guys. This next section of science is actually my favorite topics, so I will be recording YouTube or recording videos for you guys so that I can teach you about it rather than finding YouTube videos for you to watch from someone else. So I'm really excited about this. So let's get started with classifying life. Okay, so we have to ask questions in science because questions are what drives answers. So why do we classify organs? Well, there are 1 million organisms that have been identified so far on Earth by scientists around the world. New organisms, we learned, are being discovered every single day. Remember, we talked about the Amazon rainforest, and in the Amazon rainforest, 2 new species are discovered every day. That is a huge amount of species that are being discovered each year. And so we have all of these organisms on Earth, and we classify those organisms to make it easier to find information on those organisms and to identify new organisms. So we group organisms based on similarities, and we call this classification. So we classify organisms based on similar characteristics. And that's what we're going to see today. So it makes it easier for scientists to not only identify new organisms when we have a classification system, but it also makes it easier for us to learn about organisms when we have a classification system. And we're going to talk about this in just a little bit. So we first need to talk about taxonomy. And taxonomy is the study of how living things are actually classified. So what we are actually talking about today is taxonomy. And so I want to give you an example of why we classify organisms. So I know that you all know that kangaroos have pouches. You probably didn't know that kangaroos are marsupials. You also probably didn't know that possums are also marsupials, and you might not have known that possums also have pouches. So if you were to Google marsupials, you would find possums and kangaroos would pop up. And knowing that possums and kangaroos are both marsupials, you would come to the conclusion that both possums and kangaroos have pouches. So classifying organisms into groups allows us to better understand characteristics about those organisms. So when we classify organisms such as kangaroos and possums into marsupials, into the group marsupial, then we can say one of the characteristics about the organisms within the group marsupial are that they have pouches. So if we were to see that kangaroos and possums were both in the group marsupials, then we would know that they both have pouches, and indeed they do. Okay, so taxonomy is the way or the study of how living things are actually classified. So now we need to talk about how living things are classified. And that brings us to binomial nomenclature. Binomial nomenclature is naming organisms. So in the 1730s, this really cool scientist named Carolus Linnaeus created a naming system of organisms that we actually still use today. So this naming system is incredibly old, and if something is incredibly old, it means it's very efficient. So Linnaeus placed organisms into groups based on the characteristics that he could observe about them, meaning the characteristics that he could see about them. And in doing this, he gave each organism a unique two-part scientific name. And we call that two-part scientific name a binomial nomenclature. And binomial actually means two names. So we're going to look at ways that we classify organisms, with two names in the next couple of slides. But please keep in mind that Carolus Linnaeus came up with this naming procedure where we name organisms with two names. Okay, so those two names that we give to organisms are the genus and species name. So genus is the first word in an organism's scientific name. It contains the genus contains similar, closely related organisms, meaning that those organisms have things in common. So an example of organisms within the genus Felis, so we have a genus Felis, includes pumas, house cats, and marbled cats. So I've included a picture here of pumas and the house cat. And so what we're saying when we say that these animals are within the genus Felis, we're saying that they share characteristics. And specifically, the characteristics that these cats share are retractable claws and also the behavior of hunting other animals for food. So we can go even further and group animals into species. And so species is the second word in an organism's scientific name. So species describes a distinctive feature of an organism. Animals in the same species have the ability to mate with each other and produce offspring that can also reproduce. So for example, if you have ever heard of a liger, that is a lion and a tiger that have mated. They are not within the same species, and so even though they can reproduce, their offspring cannot. So that liger is unable to reproduce. So that is an example of two organisms that are not, they're not within the same species, and they don't have the ability to reproduce, to produce viable offspring, meaning offspring that can also reproduce. So let's move on from genus and species, and let's look at the specifics of binomial nomenclature. So I just told you that each organism on Earth has a genus and species name. When we write out those genus and species names, we write them in italics. And specifically, the first letter of the first word, so the first letter of the genus name, is the only letter that is capitalized in the two words. So that means that the second name, the species name, is not capitalized. Both words are italicized. And typically, or I guess all of the genus and species names are Latin words. And we use binomial nomenclature because it is a universal language. Scientists all over the world know the genus and species names of organisms all over the world. So I've given you an example here, and I'm not 100% sure how to say this genus and species name, so please bear with me. Phascolarctos cinereus, and that is a koala. So you can see a picture of a koala here. But notice two things. Firstly, that those two words are italicized. And secondly, the first letter of the genus name is the only letter that I capitalized when I wrote out that genus species name. So that is the way that we write out the genus species name. Only the first letter of the first word is capitalized, and we italicize the words. They are Latin words, and the reason that we use binomial nomenclature is because it is a universal language. Scientists all over the world know the genus and species names of organisms around the world. Okay, so now we need to talk about levels of classification because we do classify organisms into levels. So we have to ask, why do we need levels of classification? So I want you to think about something for a minute. Imagine that you are in a room with 500 people, and I ask anybody in the room who is from Indiana to please stand up. All 500 people are going to stand up. Okay, now I'm going to ask you all to sit down. Now, everybody who lives in Indianapolis, please stand up. Okay, fewer people than 500 are going to stand up because not all 500 people live in Indianapolis. Good. Now everybody sit down. Okay, now everybody who lives in Beech Grove, please stand up. Okay, now even fewer people are going to be standing up. Now everybody else sit down. Okay, everybody who lives on Arlington Avenue, please stand up. All right, now very few people are going to be standing up, even an even smaller group. Now everybody who lives in Mrs. Rock's house, please stand up. Okay, that means that only two people in the audience are standing up, myself and my husband. Nobody else lives in my house. So what I'm saying here is we classify organisms based on levels or into levels of classification because we're saying that some organisms have more characteristics in common than others. And the more characteristics that organisms share, the closer they are in relation to each other than they are to other organisms. So for example, I can place humans, a bluebird, and a robin into the same group. They are all mammals. But I can place bluebirds and robins into an even more specific group because I can say bluebirds and robins both have feathers, whereas humans do not. So what I'm saying is bluebirds and robins are more closely related than bluebirds, robins, and humans, or either the bluebird or the robin is to humans. So we use these levels of classification to show relatedness, to show how closely related organisms are to each other and to other organisms. So we have different levels of classification that we use when we're classifying organisms. The most broad level of classification or organization is the domain. The second level of classification, so within the domain, we have kingdoms. And so I've given you an example of the different levels of classification that we use over here in this diagram. So you can see, not at the broadest level because the domain is the broadest level, but at the broadest level in this classification system that we're seeing here, we have kingdom Animalia. So within that kingdom, we have grizzly bears, we have black bears, we have the giant panda, we have the red fox, we have the Albert squirrel, we have the coral snake, and we have the sea star. But then we come to understand that within kingdoms, phyla exist. So we can also classify these organisms into a smaller phylum, which we call Chordata, the phylum Chordata. Now we have just grizzly bears, black bears, panda bears, the red fox, the Albert squirrel, and the coral snake. We've taken out that sea star. But we can get even closer in relation by saying, well, within phyla, there are classes. So we can classify these organisms into the class Mammalia. And now we see grizzly bears, black bears, the panda bear, the red fox, and the Albert squirrel. We've taken out that coral snake. Okay, well, within classes, there are orders. So we can now classify these organisms into the order Carnivora. Within the order Carnivora are grizzly bears, black bears, giant pandas, and red foxes. We've taken out the Albert squirrel. It is not as closely related as these four bears and the fox are to each other. Okay, within classes, we have orders. So I just did that one. Within orders, we have families. So we can say within the family Ursidae, we have the grizzly bear, the black bear, and the panda bear. Now we've taken out that red fox. But we can get even more specific. Within families, we have genuses or genre. So under the genus or within the genus Ursus, we have the grizzly bear and the black bear. But now we can get even more specific. Within genre, we have species. So it takes us down to the species level of the grizzly bear, which is Ursus arctoa. So we see that these levels of classification show relatedness. So based on these levels of classification, we can see that the grizzly bear and the black bear are the most closely related organisms within this example. At the broadest level, we see lots of different types of organisms, but they're not as closely related as the grizzly bear and the black bear are to each other. So those are the levels of classification that we use in science. There's one more thing that I want to go over with you. We also use taxonomic keys. So taxonomic keys help scientists to determine the identity of an unknown organism. They can also help you determine the identity of something that you don't know. So for example, if you are sitting on your couch and all of a sudden you see a spider crawling up your leg and you want to know the type of spider that it is, you can use the taxonomic key to figure out what that type of spider is. Taxonomic keys consist of a series of paired statements that describe the physical characteristics of different organisms. So for example, I've given you the taxonomic key for poodoo. So when we're trying to figure out what type of organism this is, in the first step, they ask us two different characteristics. They ask us it either belongs to the class of Mammalia or it belongs to the class of Reptilia. Well, we can see that that's definitely a mammal. It walks on four legs. It's definitely not a reptile. So we're going to skip ahead to the second step. Okay, is it the smallest species in the deer family, Cervidae, or is it the largest species in the deer family, which would be a moose? It's not a moose. It's definitely not a moose. So let's move on to step number 3. It can be found in the southern hemisphere, or it can be found in the northern hemisphere. Let's see. We are going to go with it can be found in the southern hemisphere. So we're going to skip ahead to number 4. Okay. Has even-toed ungulates, which are Artiodactyla, or has odd-toed ungulates, which are Perissodactyla. Okay. We're trying to get to the poodoo, which is number 6. So we're going to say it's an Artiodactyla. It has an even-toed ungulates. Okay. So we're moving down to number 6. It either belongs to the genus Alces alces or it belongs to the genus Pudu pudu. And we figure out that it belongs to the genus Pudu pudu. So it is, Pudu puda. So it is a poodoo. So a taxonomic key gives us lots of different characteristics, statements that describe physical characteristics of an organism in order to figure out what that organism actually is. And scientists use these all the time in order to determine what an organism is or what the classification system of that organism is. So now that you understand the classification systems of organisms, hopefully, please make sure that you complete your definitions for me and submit them to me today. And then also complete that question that I asked you. Hopefully you completed the question first, but if you didn't, you can answer it now. I hope you guys have a wonderful day and an even better weekend. Don't forget that for tomorrow, you need to answer my question that I post. It'll be a really simple question for attendance purposes. So you guys have a wonderful night. Be on the lookout for that question tomorrow. Thank you guys.